Thank you very much for the warm welcome. When the call for papers for PyCon was open, I was just dealing with a lot of crap about shebangs in Fedora. And I said, let's do a talk about shebangs. And as it goes, I was procrastinating the actual talk until like 2 days ago. And I have absolutely nothing to say about shebangs. What will I do? Okay, let's try to explain them. And after that, go into some deep details. And I realized just explaining a shebang will take the full 25 minutes. So a disclaimer, this is an entry-level talk. If you already know everything, you will probably not learn anything new. But if you have no idea what a shebang is and you are still in this room, thank you very much for that. Let's start with what Peter said. I sometimes teach Python to beginners, absolute beginners. Usually those are ladies from our PyLadies courses. I teach them in Prague. And the first lesson, we help them install Python. And that's a not very funny lesson. But actually the second lesson, which is the first real lesson, the first thing that we teach them is to create a Python virtual environment. Those are free commands. I'm using Linux. Shebangs are really relevant, or any Unix-like systems, also Mac OS, but all my examples will be Linux friendly. The first command creates a virtual environment for Python 3.7. The second command activates it, and then in that activated virtual environment, we teach them to run Python with their program. And when we talk about this with other more professional Pythonistas, they're like, what the fuck? Why are you teaching on the first lesson something so complicated as virtual environments, as if anything we're gonna be using is in the standard library? And usually Python developers have virtual environments to isolate stacks. So you have one app and you have virtual environment there, something else is somewhere else. But the main reason we do this is because once you have a virtual environment, invoking Python and running Python scripts or programs is the same on every machine, including Windows, including Linux, including Mac OS. And it doesn't matter whether you run Fedora or whether you run Ubuntu. Once you have this virtual environment set up, you can just type Python and the program, and everybody in the room is in the same place. And it all comes to a very simple question. If you open your terminal, your shell, whatever you use, and you type Python, what is supposed to happen? What is going to run? What do you expect? And the real answer is that every single expectation will fail if you have a room where is 5+ people. Unless you are all Orthodox Fedoristans or something like that. It's not going to happen when you teach beginners. Some people will get Python 2.7, at least a relatively fresh version. Some other people are already over the bridge and they will get Python 3.7. Some other people will get 3.6, which is not that bad. Some people like me will already now get 3.8 because we need to test stuff on what's not yet happened. And some other people, like Peter, who introduced me, are probably too far away because they are CPython developers. Sometimes you get something really old when you have Mac OS. Sometimes you are crazy and you actually got PyPy. Nobody ever gets Jython because it's dead. But the problem is that currently, very, very big amount of people will just get nothing, even if they have Python installed. On Fedora, half of my system runs on Python, whether it's the packaging manager, whether it's the system tools, whether it's the installer, it all runs on Python. But if I type Python, I don't get that command. And that's because according to the upstream PEP that defines what should happen if you type Python, that we are currently trying to change, it says Python is Python 2. But you don't get Python 2 pre-installed anymore. You get Python 3. But you type Python and it's not there, and people are surprised. And they try to install it. And this whole mess is because we Python developers tend to have at least 15 installations of Python virtual environments. We use venvs, virtual envs, pyenv, conda, pipenv. Somebody uses poetry, somebody uses Docker containers. Obviously, there's just one way to do it, but it's just one too many. This is an XKCD comic about Python installations and where you install packages, and it's a huge mess. And who's been doing Python for a while, especially if you develop libraries that need to support multiple stuff, you know this mess. And every sane person would say, this is just damn crazy. Why would you ever do that? And then try to teach something about it. So that's the reason why we say yes to the virtual environments, and that's the reason why we want everybody to run the same. And it's quite easy once you learn that. The real problem is, if you don't just want to teach people program, but you want to ship your applications. Because if you want to ship something, you need to make sure it's going to be delivered. And it's hard to explain virtual environments to Python programmers. I can't imagine it's explaining them to my users. If my users are supposed to run my app, I just want them type the command, run the app, not create a virtual environment and stuff like that. Here are some examples. The YAM, or now DNF, is a package manager on Red Hat Linux and Fedora. And if you run this command, you don't even know if it's written in Python. You don't really care whether it's written in Python. It should just install the damn package. The same way, if you want to provision your machines with Ansible, it happens to be in Python, but why should I care? I should not need to create a virtual environment. It goes on and it goes on. I just want to download the damn video. I don't want to care about virtual environments. I want to do some requests and stuff like that. Especially important, this is Mercurial, which is something like Git, but presumably somebody says it's better and somebody says it's worse. I don't really care. What's important is that's written in Python. Now imagine you would develop a Python application and you would use Mercurial to develop it. And you would need one virtual environment to do your coding and another virtual environment to run the version control system. That's just bam, bang. Anyway, there are lots of tools that happen to be written in Python, and the users don't care. They don't need to care. And unless they are enthusiastic about Python, they just don't know. So what we really want to do is just create some command. Some command that you can say, run this, and it's going to run. And what does it even mean to have a command on a Linux-like system? Is that you put an executable file into your path. And this is a two-dimensional problem, because not everybody knows what an executable file is, and not everybody knows what path is. Let's talk about path. This is this special variable I have defined on my system, and it contains some directories. And these directories contains files, executable files, that we can execute to run commands. And if I look for a directory like this, for example, my favorite one, user bin, because it has a lot of stuff. If you have a Linux laptop here, you can look into user bin. There will be lots of file. Here are just some random 10. Surprise, surprise, one of them is Cowsay. We installed it previously with Yum, and we're going to look at it. In order to run it, it needs to be executable. This is a matter of permission, and those X's in there means execute, and it gives us the right to execute the file. How can we execute it? Well, if we know where the file is, we can execute it by typing the path into the shell. So this is a cow. It says hello to PyCon because we typed user bin cowsay. We can also do it with relative paths, but most importantly, we just want to say the damn command, and we are back to the original problem. And this works. And this works because user bin is in my path, and cowsay happens to live in my user bin. If I look back to the path and split it to the several parts, well, when I type cowsay, it looks here and it's not there. And it looks here and it's not there either, and so on, until the command is found and is executed. However, what does execute actually mean? You can execute an order, or you can execute a command. And in order to understand that, let's step aside from Python and look for compiled languages. I bet you know some compiled languages. I picked a favorite one. This is Rust. It's a very complicated program that runs hello from Rust. And it's compiled, so you need to compile it in some sort of magic file that can run, that can execute. What happens is that after you compile it, you get a hello file. And if you examine what kind of file this is, and I'm going to read it because I have no idea, and it's an ELF 64-bit LSB Pi executable. And when you first see it, you're going to probably say, what, ELF? On LSD? In a Pi? But no. ELF is actually an executable and linkable format, and it's a way to say, here are the stuff you can execute, and the other stuff is least significant byte and position independent executable. But this talk is not about this kind of stuff. That would be a completely different talk. There was a talk about debugging the previous session, so if you want to learn more, come back in time and see it. ELF is a Linux specific format. On macOS, they get something that's called Mach-O or Machos. So either you get ELFs or you get Machos. Either way, if you execute the file, if you put it in the shell by the path, it runs. Because the shell that executes the stuff, it knows it's an ELF. How does the shell know whether it's an ELF? It's easy. If you Google how to recognize an ELF, this will be the very first thing, at least in my browser, you know. So this is a binary file. Every file is binary, but this means there are just some bytes. And the first 4 bytes are quite important. 7F, 45, 40C, and 46. Also in ASCII, the 3 of them are ELF. So if you dump the file, it says, I am an ELF at the beginning. And so it just works. However, our Python program is not an ELF, because Python is not an Elvish language. So if we try to do this, if we have print hello from Python, first, when we try to execute it, we don't have the permission. So we can use the change permission command to give the permission to us. And then we execute the file, and it starts doing syntax errors on us, which probably for a beginner doesn't even make any sense. What happened now is that the shell recognized that this is not an ELF, so it tried the only thing it understands, execute the file line by line in the shell, which in this case was bash, and unlike Perl, Python is not valid shell and it doesn't work. And that is why God invented shebangs, and this is what my talk will be about shebangs. So that was the introduction. Do you remember the cow? It's written in Perl. What's important about Perl, if you don't know it, it's that it's interpreted like Python. And it's not Python, it's a different language. That's all you have to know about Perl. That's all everybody needs to know about Perl. So if we hex dump the user bin cowsay, we don't get the 4 special bytes. It's not an ELF, but it has different special bytes, 23 and 21. And this is the shebang or the hashbang. Those are 2 signs, the hash mark that you use in Twitter for hashtags, and the exclamation mark that you use for being more important or whatever. So actually, if you read it as a text, the first line of this says, hashbang or shebang user-bin parallel. This is a very magic line, and it's called the shebang. Disclaimer, there are a lot of shebangs. You can have various different shebangs. That was not a disclaimer. I am one slide ahead here. Disclaimer, this is not going to be about a shebang, an Australian radio show. It's not going to be about this Swedish pop group called Shebang, neither this Canadian breakdance crew called Shebang, or Shebang, a character from the cartoon Static Shock, or even a music or dance show mid-1960s called Shebang. Do not confuse with Shebangs, a song performed by Ricky Martin. End of disclaimer. Let's see, how does this even work? If you need to understand how Shebang works, create a file and put an easy Shebang that you understand. Put an echo in here, user-bin echo. Then if you run the file, now I'm going to try to draw, which is going to be probably too complicated on my touchpad, but I'm so shaken. Okay, this is the first line. Sorry. Was the first line, then you execute it in here, or you execute it in here. And what actually happens is that the first line, without the special marks, gets executed and gets the entire thing you type in here as an argument or as a couple arguments. I hope you will forgive me for my drawing skills that are not very good. You can do crazy stuff. You can do self-destructing files. This is my favorite script. You put a shebang, user-bin remove. It doesn't really matter what you put in the rest of the file. It can be a secret message that will self-destruct after executing. And if you execute it, it does what shebangs does. It does user-bin remove the file. So it's a one-time file that doesn't do anything else, then deletes itself. It's very useful. Let's start with Python, except it doesn't work because I don't have user-bin Python. Meh. So let's forget the user-bin part and go back to echo. Yeah, I have Python in different places, you already know that. If you try to use a shebang without an actual path, it doesn't work. You have to use a full path. So this is my Python. It lives in my home, so I can ship this to customers, but it doesn't live there. So I can only ship my own computer, and that doesn't scale. That's why there is a special command, user-bin env, that you can say Python, and it will search for Python into your path, and it's magic, and it works. Until it doesn't, then you want to use a flag, it breaks. So you need to add a flag to support flags, or from, yeah, this is crazy. And what's also problematic, and that's most important, is that imagine a system tool like a Mercurial version control system. If this has the env shebang with Python, it means Python, whatever it does when you type Python. So you create a virtual environment, and you need to program something, and then you want to commit it, and it blows up. Because Mercurial doesn't work with your Python, it works with different Python. And this is the very sad story about shebangs. Those are all shebangs that you can imagine. There are plenty of more Python shebangs, and they have one thing in common. None of them works on every computer. None of them. Most of the upstreams are trying to work around it by doing autotool templates with variables in the shebangs. And everybody is just so damn sad about this. What should I write there? What should I put in the shebang to work on my computer, on your computer, and on your computer? And the answer is quite simple. Just don't. Because if you don't have shebangs, there are no problems. And to finish the message, if you are using setup tools or any other single one way to do it, obviously, you can use a super cool feature called entrypoints and console scripts where you describe the full path to your function. This is quite comprehensive on one slide. So let's have an example. Let me try to draw a little bit more. You liked it before. So this says the hello command will be in this module at this function. And then you have this module, and it has this function. And if you install this package with pip, you ultimately get the hello command. And if you install it in a virtual environment, it only works in the virtual environment. If you install it system-wide, it works system-wide. If you install it user-wide, it works user-wide. It actually works. And it has crazy shebangs that are not portable. You cannot install it and then ship it. But everybody can install it, and it just works. So the general message, and you can use this even without setup tools if you're using Flit or Poetry or whatnot, is never ever try to write a Python shebang by your own hand. And if your IDE is doing this for you, just delete the damn line already. Thank you.
Thank you, Miro. Do we have any questions? Oh, we do. How do you target by shebang an interpreter that has a space in its path? Neither quotes nor backslashes work.
You don't put spaces in paths. The only reason to put spaces in paths is to piss off students at university in tests and practical exercises. Just don't use underscore like any normal person would do. Or dash, if you must.
A good question, though. Does anybody have another question? No.
How do you handle an interpreter with a new line in the path?
So my question is, as a developer, if I have this way that you used, I sort of miss the scripts, the commands that I would like to use as a developer during the development phase. How do I solve that?
How do you have your own scripts in the project that you are supposed to run?
Yeah, for the same purpose as the scripts that you install.
There is plenty of ways to do it. One is rather complicated to learn, but very useful and very flexible. It's called invoke, and it's like a framework, but really just put a function in there, and then you can invoke the vendor or invoke whatever. It does jobs. What other likes are still using make files for such, and if you are writing something that's targeted to the developer, that's you or other developer, you can always just write it as a Python module and execute it with Python, your Python, the Python you want to execute, -m, name of the module, which is very friendly for people who do this for venvs and pip or whatnot. And you have very high control of what Python is this being run on. But for developer, this often means a lot. If you run a command, you need to know what Python you run it on. So you don't want to just put the command in, because that's not flexible. You have no idea what Python this is being run on. But if you use Python -m, the name of the module, you are in the control of the Python interpreter.
Thank you.
When I run dnf install some package, dnf will unpack the package, basically. It no longer runs setup by. Technically, I could create packages that do this, but that would be super evil. What you do is that you run setup by when you create the package, when you build it on the server. Because Fedora is not Gen 2, we don't use user machines to build stuff. We use cloud machines, somebody else's computers. And then we use setup by with some flags and stuff, and we make sure the shebangs there are right. We also sometimes change the shebangs to be more specific than less specific, because it matters when it's in the package. For more reasons, I'm not going to talk about it. It would be another talk. And then you just unpack it for the users.
Can you call a Python script that has its own virtual stack without explicitly activating the venv?
Yeah, if you installed it in the virtual environment, it has the shebang with the virtual env baked in it. So wherever from you invoke it, it's going to have the stack from the virtual environment, which is quite useful. You can create a virtual environment, install some app in it, and then just symlink the executable file to your path. And whenever you execute it, it has the dependencies from the virtual environment. I have a couple of virtual environments for custom interpreters, so I can have IPython for PyPy or stuff like that.
Thank you. Any more curious questions?
They just want to hear the lightning talks, I guess.
Okay, well, thank you, Miro.
You're welcome.